Okay, I'll start. Good morning, students. In the last class, I started the chapter test execution. In that, I explained what is the test execution, then how to automate the test execution by using different testing tools. Then the construction of the test cases for the given specifications. Then you have studied about the example for the test case generation and the execution. After that, I explained the scaffolding. What is the scaffolding? Why do we require the scaffolding? What it includes? It includes the test harness, drives, and steps that I explained in the last class. What is the test drive? What it consisting of? What are the test steps and test harness? How they are helping in executing the test cases and identifying the faults in the implemented program or in the developed software that I explained, and how the scaffolding provides the controllability and observability that I explained already, and what are the generic and specific scaffolding techniques. So whether the scaffolding is a generic one or the specific one, if it is a specific scaffolding, what happens? And why we are going for the generic scaffolding that I explained in the last class. Today you are going to study about the oracles. So oracles are nothing but the test oracles. Simply we are calling them as the just oracles. Okay. Oracles are the test oracles, but simply we'll call it as a, or in general we'll call them as oracles. As we know that whenever we are going for the testing the implemented program or the developed system, we are making use of the test cases, and the test cases are constructed for the given specifications, and those test cases are we are using on the implemented program or the system. When we are using the test cases in order to run the implemented program or the system, it may involve the human intervention, as I said before. So, the human being can verify the result after applying the test cases or after running the implemented program by using the test cases. And what are the problem arises when the human is verifying the result? So the system may leads to slow because the humans are not fast when compared to the systems or the different testing tools, and there is a possibility that the error may occur because even though the human is a conscious one and hard working person, but he cannot continuously see the result which is obtained on running the program. Right, it is very difficult. He cannot continuously monitor the testing the process. So then the fault or the error occurs in testing the systems. So in order to avoid that, we are going for automation of the testing tools, or we are going for automated testing process. In the automated testing process, we are going to make use of the testing tools, so that those testing tools are continuously monitoring the are continuously testing the implemented program or the system. Then what are oracles? So a software that applies a pass or fail criteria to a program execution is called as a test oracle, or it is simply called it as a oracle. So understood what is a test oracle? It is the software that applies the pass or fail criteria to a program execution. Suppose let us consider that I have implemented one program and I am executing that program by using the different test cases. Then the software that it tells whether the obtained result is pass or fail. That is informed by the software, and that process is called as a test oracle. Or that method is called as the test oracle, or simply we call it as a oracle. Okay, understood? Just a minute. Suraj, classic connect ಆಗಿಲ್ಲಲ್ಲ ಯಾರುನು? ಇಲ್ಲ ಇಲ್ಲ ಈಗ ಬರುತ್ತೆ ನೋಡ್ರಿ. ನಾನು ಅದಕ್ಕೆ ಎಲ್ಲರಿಗೂ ಫೋನ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಯಾರು ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂತ ಇಲ್ಲ. ಶರಣ್ಯ ಒಬ್ಬರೇ ಕನೆಕ್ಟ್ ಆಗಿದ್ದಾರೆ. ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ. So what is a test oracle? Software that applies a pass or fail criteria to a program execution is called as a test oracle, or simply it is called as a oracle. And when we are performing the test execution, we have to classify a large number of test cases for executions. And automated Oracle makes it possible to classify the behaviors that exceed the human capacity. So, as I said, we are using the test cases for testing the implemented program. As we know that we are going to construct more number of test cases, then if more number of test cases are constructed and classifying them according to their behavior, it's very difficult by the human being. Then we'll take the help of the oracle or the test oracle. So it automatically, what it will do, it classifies the test cases based on their behavior, okay, or based on the test case execution behavior. Understood? So as I said, when this test case is applied in order to on the implemented program, then we have to check whether it is a succeed, means pass or fail. So to do that, we are using the test oracle. So no use running 10,000 10 cases automatically if the result must be checked by the hand. As I said, if the human intervention is there, or the human being is testing the result of the 10,000 test cases, it is very difficult because human cannot continuously monitor the testing process, and hence we'll go for other type of automation, right? So the range of specific to general again. So for example, if you consider the J unit, so it is a specific oracle coded by the hand in each test case. So this is the specific test oracle. So as is studied in the scaffolding, whether it is a generic or the specific scaffolding. Similarly, we have the oracle. It may be the generic oracle or the specific oracle. So if it is a specific oracle, for example, just like the assertions, these are coded by the hand, means coded by the human being for each test case. So then it is very difficult. So for each test case, construction of the specific oracle is very difficult and time consuming also. And since we are constructing the specific oracles, then the cost also increases. So then hence we have to go for the general one instead of the specific oracles. So here what happens, we'll go for the approach called as the comparison based oracle or the comparison based approach. So in the comparison based approach, when you're using that comparison based oracle, what we will do, we will compare the obtained output with the predicted output value. Okay, so here we are comparing the predicted or expected output with the obtained output. If both are matching, then we say that the test case is pass, otherwise we'll say that it is failed. And this is not the only approach. Like that, many approaches are available for the test oracles. So as I said, so this comparison based test oracle, it included in a test harness program or framework. Okay, so the comparison based oracle is included in the test harness program or in the testing framework. And as I said, it consisting of two things. One is the input and the other one is the predicted output, because whatever the program we are testing, we need to give the input, right? And then we'll compare the obtained output with the expected output. Hence, so the comparison based oracle consisting of a pair of input and the expected output from that program. So here we'll see the comparison based oracle. So this is the diagram for the comparison based oracle. So here, as I said, we are constructing the test case consisting of the test input and the expected output. Okay, so input we have to give, obviously, right? So the test case consisting of a pair of test input and the expected output. So this test input will be given to the program which is under test, means the implemented program that we are testing. For that we are giving the test input. Then once we give the test input, it gives the output, right? So once the program gives the output, that output is compared with the expected output. Okay, that output or the obtained output from this program is compared with the expected output. If both are same, if both are matched, means expected output and the obtained output is matched, then we say that it is false or the test case is passed. Otherwise, the test case is failed. Okay, so this is the diagram for the comparison based Oracle. So it included in the test harness or in the testing framework. So as I said, with a comparison based Oracle, we need the predicted output for each input. So whatever the input we give for each input, we need to know the predicted or the expected output. So the Oracle compares the actual to the predicted output and reports failure if they differ. As I said, so it compares the obtained output from the program with the expected output. If there is any difference between them, then we say that the test cases is failed or the Oracle or the implemented program is failed. And this type of method is works well for a smaller number of end generated test cases. Okay, so comparison based Oracle works fine or it is well suited for a small number of end generated test cases. So if more number of test cases are there, then it is using the comparison based Oracle is the uh, what happens, the cost increases because we cannot use it, because for each input we have to compare the obtained output with the expected output, so it takes more time and the cost increases. So this works well only for the finite number of or small number of and generated test cases. The example is for handwritten JUnit test cases. So next we'll move on to the self-checking code as the Oracle. So an oracle can also be written as self-checks. Means what? So to check the correctness without predicting the results. Seer simply will give the input and the program gives the output, and that output we are going to judge whether it is the correct output or not. If it is not the correct output, then we'll inform the failure about that system, or notification is sent about the failure. Okay, so this is for self checking code as the Oracle. So this is also included in the test harness. See here we have the program under test. Suppose let us consider the same triangle program. If you have implemented the triangle program, then you have to test whether that works correct or not for the given input. So here what happens, in the previous case here, in the comparison based Oracle, along with the test input, we are also providing the expected output or the predicted output. So then once the program gives the output, that output is compared with the expected output. Then after the comparison, we'll say the result as pass or fail. But in the case of self-checking code, no predicted output or the no expected output is included. Only we are giving the inputs. So the test case consisting of only the input, and that input is going to given to the program which is under test. Then once the input is given, then the program gives the output, and that output we are checking manually whether that output is correct or not. Clear? And this type of checking is called as the self checking, and here we'll use the self checks code for the Oracle. So then what is the difference between the previous one and here? So in the previous one, the human intervention is needed to compare the result, to compare the expected output and the obtained output, and to check whether the test case is passed or failed. So for this we need a human intervention, and it works only for the finite number of and generated test cases. But in the self-checking code, since we are not using any expected output, or we are not including any expected or the predicted output, simply we'll give the input. Then the self-checks codes are included in the test harness, and that simply checks whether the obtained output is correct or not. Okay, so this is called as the self-checking code, as the our self-checking code is acting as the Oracle. Okay, then what are the advantages and the limitations of self-checking code? And this type of Oracle can be used for large automatically generated test suits, but it performs only the partial checking, not full, not it performs the full checking of the system. Okay, understood? So the advantage is it this type of Oracle or self-checking Oracle can be used for the large and automatically generated test suits or the test cases, but the limitation is it performs the only the partial check. So the example for this is structural invariants of data structures, because it recognizes many or most failures but not all the failures. Okay, so some the are only the partial checking will be done by using the self-checking code, and it is best suited for large and automatically generated test cases. But the main limitation is it performs the partial checking. So next we'll move on to the capture and replay. So what is a capture and a replay? So when we are performing the testing, so as I said, we are using the human intervention. Our human intervention is required. So for some of the programs or for some of the testing cases, there is no alternative to the human input and observation. We require the human intervention for observing the output and to give the input. So the best example is when we're using the graphical user interface. So we will separate the testing program functionality from the graphical user interface, because some testing of the graphical user interface is required, and that cannot be done by using the self-checking oracles or by using the comparison based oracles. We have to go for the human intervention, or a human being is verifying the uh, test, or a human being tests the graphical user interface that is developed. Because for the graphical user interface we have to give the input, and then afterwards we have to check the output of the graphical user interface, and there is no alternative for the human intervention there. So for such a testing process we need the human intervention, and we can at least cut the repetition of human testing. So here, since as I said, we cannot or the human being cannot continuously observe the ನಿಖಿಲ್ ಈಗ ಜಾಯಿನ್ ಆಗ್ತಿದ್ದೀರಾ? ಓಕೆ. So a human being cannot continuously observe the testing process, because he's a human being. He needs some rest, right? He cannot continuously monitor the testing process. So then what we can do is we can avoid the repetition of the observing procedure by the human being. So that is the case, right? We can at least cut the repetition of human testing. Suppose we are testing the graphical user interface that is developed. So what we can do for one or two test cases, here we can involve the human being to verify the result. But after that, once we are continuously using the testing process there, we can avoid the intervention of the human being. So we can cut the repetition of human testing. So to do that, we are making use of the concept called as the capture and replay concept. So why we are going for capture and replay concept? For some of the testing systems, we need the human intervention. There is no alternative for human input and observation for some of the testing methods, or for some of the testing programs. The example is the testing of a graphical user interface. So when we are testing the graphical user interface, so what happens there? We need the human being for giving the input and to observe the output, and it is a continuous process, and that continuous process cannot be monitored by a single person, right? Then we can avoid the continuous monitoring by the human being by using the concept called as the capture and replay concept. Or capture and replay method avoids the continuous monitoring of a testing process by the human being. So for that purpose, we are using the capture and replay. Understood? In order to avoid the continuous monitoring process by the human being, we are using the capture and replay method. Okay. So we'll see what happens in the capture and replay method. So in the capture and replay method, what we will do, we'll capture the test case which is running manually, and we'll replay it automatically, and that is called as capture and replay. Suppose let us consider an example of the commission problem, right? That commission problem you have implemented and you are checking that program. So there we want to use the capture and replay. What we will do once, in the first step, we are running the test case with the help of the human being. So when the test case is run with the help of the human being, there we are capturing the test case manually, and after that, that same test case is applied automatically on the implemented program, and that is called as capture and replay. Replay means running the same test case again and again automatically without involving the human being. Understood? Okay, so capturing means capturing the test case which is running and capturing that test case manually. After that, applying the or replaying the same test case automatically on the implemented program. Understood? So capture and replay. Okay, capturing the test case and running the same test case again and again automatically without intervention of the human being is called as replay. So with a comparison based test oracle behavior same as the previous accepted behavior. So what we will do, so here we are running the test case automatically, right? Then how to compare the behavior of, or how to compare the results with the predicted one and the what the obtained results. So how to compare the obtained results with the predicted one. So for that, what we are going to use, we are considering the previous output which is obtained for running the same test case. Okay, so let us consider that in the first step the test case is executed and we got the output, right? That output we are using to compare with the future result. Okay, so with a comparison based test oracle, we are using the behavior same as the previously accepted behavior, or if you consider the output which is same as the previously accepted output. And this test case is reusable only until a program change invalidates it. Okay, so we can continuously make use of the same test case until the program invalidates the test case. So until there is a validity for that test case, continuously we can run the same test case, and that test case fails when the program invalidate that test case. If the program invalidates that test case, we cannot use it again. Then we have to go for other type of test cases. And the lifetime of this test cases depends on the abstraction level of the input and output. So whenever we have constructed the test cases, we have included the input and the expected output in the test case, right. So when we are running that test case, then the lifetime of that particular test case depends on the abstraction level of the input and output. So it may be running for the longer time or it may be running for very shorter time. So that is depending on the abstraction level of the input and output. So this is about the capture and replay. So far we have discussed about what the test oracles, then the self-checking code as a oracle, and third one is the capture and replay. These things I covered in this class. So we'll see the summary of the chapter. So here the main summary of this chapter, or the main goal of this chapter, is to separate the creative task of test design from the mechanical task of test execution. So then how we are doing it? Uh, by using the different testing tools, and those tools can be run automatically, and enabling the generation and execution of the large test suites, and re-executing those test cases which are present in the test suite frequently again and again. We can make use of the same test cases, or we can execute the same test cases. And next we are going for the scaffolding. So in the scaffolding, we have studied about what is the scaffolding, why do we go for scaffolding. So what is a scaffolding? It is the additional code to support the development and testing of a system, and it includes the test drivers, the steps, harness, including the oracles. And this scaffolding ranging from the individual handwritten test case drivers to the automatic generation and testing of the large test suites, And next you studied about the capture and replay where the human interaction is required. The best example is testing the graphical user interfaces. There we require the human intervention, but the human cannot monitor the testing process continuously. Hence, we go for the capture and replay technique. In the capture, what we are going to do, we'll capture the test case at the runtime, or will capture the test case when it is running in the manually. Then we'll apply the same test case again and again automatically. There no human intervention is required. So these things you have studied in this chapter. If you have any doubt, you can ask. So what are the things you have studied in the test execution chapter? First, you have studied about what is a test execution. Why do we require the test execution? Next, you have studied about the scaffolding. In scaffolding, you have studied about what is a scaffolding, what are different types of scaffolding techniques, or what the scaffolding technique includes, that you have studied. And afterwards, you have studied about the test oracle. Test oracle is simply called as a oracle, and what it consisting of. So next you have studied about the comparison based test oracle, and after that you have studied about the self checking code as the oracle, and these things you have studied in test oracles. After that you have studied about the capture and replay. Why do we go for capture and replay technique? So we'll use the capture and replay method when the testing process requires the human interaction and the human observability. There we will use the capture and replay technique. Example is monitoring the testing process or testing of the graphical user interface. There we require the human being for giving the input and to observe the output. So in order to avoid the continuous intervention of the human being, we are using the capture and replay technique. So this is about the test execution, and the chapter is completed. In the next class, I'm going to start the new chapter. Okay. If you have any doubt, you can ask.